Very simple example how I transfer a model from Unreal to TouchDesigner. Let's go TouchDesigner. We start with Unreal is a game engine, 3D engine with very known through all the industry. Many big studios are moving into Unreal. Download the content example. And in this project we can change between examples of labels like particles, physics, animations. But before I jump into particles, before I jump into any of the more specific areas of Unreal, do a very simple task of trying to start to take the whole model that we're seeing here and move it into TouchDesigner. For that, first of all, we need to ask ourselves which object we want to place in TouchDesigner, and make it short. I found one of the more important pieces here. So we will import this piece, and afterwards we will also import this piece, or not exactly this one, the smaller one, this one. That will be our two pieces that we are going to transfer into TouchDesigner and try to render it more or less in the same way it looks here. We have an assets in Unreal, so we right click on the asset that we want to export. Asset actions, okay, export, and we're going to export as FBX. So let's create FBX2. And we want also to export this piece. Again, selection, export, and let's save it also on FBX2. There is another thing that we need to also transfer. Not only the mesh, not only the geometry, we need also to transfer the nice edges here. This is a normal map. This comes from the normal map, and I will show you how it works. But first of all, let's see how Unreal, how they dealt with the shader, how they created the normal map and what's the meaning of the normal map in this case, and how it's structured in the material. Okay, shallow. Here is the material. This is the instance of a material. We're going here again, and here we see how the material behaves. And the first question I ask myself, if there are any maps that I need to bring with the model. So no textures, no additional textures. This is a color parameter. We have another parameters. We have a texture sample of something very white. Maybe I'm not notice. I don't think it's anything important, but the important part here is the texture sample that we see here. And as we can see here, you can more or less understand that it's responsible for this behavior of the little edges here. How to say it? Like
the tiles in the floor.
Tiles there? Okay. So I'm double click on the texture. I'm going here, and let's make it bigger. Let's find it in the editor. Just the same. Right click, export, asset action, export, and we place it in the same FBX2 folder. So we have two models. The other one, I'm already saying it's not contain any textures, so we are not going to deal with it. So two models and one texture of the bigger model. And important to notice how they dealt with the normal map. So what they did basically is just multiply the normal map with half of the R and G channels, half, like you can see, multiply 0.5 multiply R and G channels. So it's 0.5 and 0.5. And we create like we create a vector and we add it to another vector which is 0, 0, 1. So we get 0.5, 0.5, 1. And this then that multiplied with the texture sample of the normal. With TouchDesigner, there are many ways to do it. We do it in the simplest way with GLSL. I will just give you an example. But it's important to understand and first of all ask yourself how in Unreal the material deals with the textures. Or even we have the PBR model. PBR model is a model that responsible on how geometry will appear in your rendering. It's taking account the lights in the scene, it's taking account the camera, so in the end of the day it will be able to render it. That's something you can look on PBR rendering for more information. And you can see here we have metallic, we have roughness, and we can see here the parameters. It's important to take a look before you jump into TouchDesigner. TouchDesigner and Unreal, both of them have PBR rendering model of roughness model, so it's pretty straightforward, more or less the same. Okay, let's close Unreal. The process to take a model to TouchDesigner and try to render them, it's harder than in Unreal. It will take more time to set it up. Also, we need to do some massage to the models themselves, and you will see why. So we're going to the folder that we have the FBX theme. Let's first of all import the texture, import the, I don't know how to say it, the screen, the base, and the major room piece model. Let's start with the big room piece. And let's dive in. And first of all, after we dive in, we see some kind of export anim and text. We don't need it. That's for animation. That's when you have a rig. When you have animation in your FBX, it's important. Then you have channels, and you can see and you can export and you can process them. That's important, but for our case, we don't need it. We delete it. So we have another container. Let's dive in. And we see material, and we see the mesh itself. And the material, in this case, I will also delete because we want a PBR model material. And before that, this is a foam material, so it's not helping us. We want a PBR material. As you noticed, we have two containers. Let's place the geometry into one container. And so let's catch the SOP. This is the actual geometry. You see, I middle click and I can see the number of points or the information about the geometry. We can see the attributes. We have UVs, we have normals. And let's take it out, go up, delete. So right now we have only one container and one mesh. Let's create a null. And let's understand that. I mean, we can look on that screen and see that it's not aligned properly. You see that the Z and the Y are replaced, changed. So we can like fix it now. Let's go to a better viewing. Let's here the blue is for displaying inside the OpenGL viewer, and the render is actually allows it to be rendered if we initiate the render. We haven't initiated the render yet, so it's not matter, but for now we have the OpenGL display, and we can see that is really huge. So most of the time, let's say in Unreal, the ratio between Unreal to TouchDesigner is 1 to 100. So we need to reduce the size 1 divide 100. So let's multiply it. Let's do a transform and multiply it by 0.01. It's very important when we deal with PBR, with physical-based rendering. It's very important to keep proportions and very important to know what's the actual size of the geometry that you bring into your scene. now we can see, okay, how we see that it makes sense. Let's take a box. Just take a box up. And box up is 1 meter, cubic meter. 1 on 1 on 1. So we'll see if it makes sense. This room makes sense. And we remember how it was look like in Unreal. Let's make merge. I merge between the two, and you will see that it's, you know, it makes sense. Like, I think there are like maybe 10 or 12, and the room overall was 24 meters. So yeah, I can more or less say, okay, it makes sense. We don't need the box anymore. What else we need to do? We see that it's not orient right. Let's look on the X. We see that we want it like, okay, that's depend on your decision, but in this case I will prefer to rotate it on the counterwise. Like if the X is our axis to rotate on, we will rotate over here. So let's rotate on the X on minus 90, and now we have the same orientation, the same size as we saw in Unreal. But we remember in Unreal we lived in some kind of a room, not in open space here like all this space. So let's duplicate it and close it, at least from one side. Let's just rotate it and put another one in front of it. How we do it? There is a node called copy SOP, and what it does is just copy geometry, copy surface operator. We just going to add it to our chain, and we need another copy too. And let's try to rotate it in 180 degrees. And we see like that our axis is like exactly here. You see, our axis is on the 0 of the X. So if we could just move the pivot, we can close it and do it like the rotation, right? We can also do it parametrically. We can also do it expression-wise and not be dependent on playing with values. I'll dive into it again and look, because parametric-wise there are other meanings to that. Okay, so we have the object, but let's multiply it 5 times now. We can also take a copy and then move it. We can also just do another copy. But let's introduce another way of using a copy SOP. And that's using a template. That's using a lines. A kind of way to use a copy SOP, and that's with a template. I connect the geometry I want to copy. I'm taking the template, the line. Here you can see the line. It starts from, in this case, from 0 on the direction of X and distance of 1. And let's change it. Let's take the copy parameter and let's paste reference, and let's make it minus. Let's make it minus. And if we take here so we can see, let's put it here. Let's put the number of copies. That's 5. Now I can control the line. Sorry. 1. and the number of points we change to 5. And if we change the line length, you can see we can build.
Nice.
And now, as you can see, we have more control. When you start to do rotation and scale, and it can work, but if you can divide it, it helps you to keep your. So, anyway, maybe you're right. I need to check it. Let's connect it. Yeah, I think it's good enough. Let's go inside. And it's not very noticeable, but we can see that there is a problem with the normals of the geometry. How we look on the normals? We're going to display options, right click, display options, and let's look on the primitive normals. I'm not sure, but it will be a bit more of work to see if there is a problem that way, but that's also one way to check. What we want to be sure of, that each primitive have also normal correctly. And in this case, I think there is a problem, because you can see on the upper on the top, none of the normals pointing up, everything pointing down. You see here? No, here you don't see any normals. Maybe one. Where are the normals? So if you want to correct it, we're going to copy, we're going to face it, and we're saying two things. One, make normal unit length, which is not really matter, it's not going to change it's not going to change anything besides the length, like the direction stays the same, but is also important for other calculations. So I'll make normal unit length 1 and compute normals. And now we have some kind of we have a change. Let's see what's the change. And if we look between the two versions, we see there is a major difference. Yeah. Okay. That's one. So, and that's for a PBR rendering. We need also the tangents of geometry. So for that, we're going to create attribute create in the SOAP, and we compute the tangents. I think that in the facet we can close the compute normal and just do it here. Yes. So we only use the facet for make it a unit length. I'm not sure that we even need it, so we can throw it away. And create here compute normals and compute tangents in the create in attribute create. And now we are ready with our first geometry. Let's close it. No, sorry. So let's concentrate on this geometry. We remember that we have a affiliated texture with it, the normal map. But to use the normal map, we need PBR material. So we have PBR material, and we drag it into our room material. It's not giving us anything right now. And let's start to render it. Let's create a render top. And let's cancel it for a second. This base. Render top needs also, we will say, hey, I need a camera also to know where to render, like where to project on my render. So let's go to camera. And as we can see now, not really clear where we are, I can take the camera up, but I want to make it visualize for this explanation, so it will be more easy to follow. So the camera is on the Z, and we will elevate it. Once I will do it, you will be able to see. And now we need a light. We don't see anything here on the render, so let's add a light. Also the light, we need to bring it up, and it's a point light, and we'll do a distance attenuation. It means that it used the square, how do you say it? The more distance, the energy will reduce in the square of the distance. Will be divided with the power of 2 of the distance. Let's take it here, and we can see, okay, that's one. And now I want to configure now the PBR material and how the texture we're going to work with it. We can already like drag here, we have maps and the PBR weight for normal map, for example, in this case. And we're not yet able to see anything regarding this change. Let's reduce the roughness. Let's reduce the let's keep it that way. Metallic, and reduce the metallic, maybe 0 bit. And let's move the camera and the light together, so we will not look on the connection of the two of the pieces of the room. So let's move it a bit more. Okay. I want you to notice now. Let's close now let's look on the render now. I want to show what's this normal map, what the normal map are doing in this case. If we will go to the maps and move away the normal map, we're losing these edges. And we return it, we have it. We can change also the bump scale here, but if we remember in the Unreal how they multiply, you remember how they multiplied the R and G by half and kept the blue channel to be 1. So for the sake of just in case you really need to dive into it, I will show a very simple GLSL example. There is also ways to do it just with nodes. I can show it also, but I think that's very simple. Let's make another node. And let's drag the node here to the normal map. And here we need to change because right now, okay, GLSL very quickly is dealing with each pixel of the texture parallel. So we feeding this texture into the GLSL code, and I'm going to delete. You see right now it's getting white. You see vec color gets vector of 1, everything is 1, and frag color getting all the color inside. So it's only 1, 1, 1. So let's cancel it let's bring the color of the texture, and we have the edges. But if we want to be precise and mimic the same Unreal operation, we can write this code. We can go color, because right now color represents each pixel in the texture, but we are going to multiply only the R and G channels by 0.5. Each pixel RNG channel is going to be multiplied by 0.5. So it's multiply equal 0.5, and that's what we get, like that's the equivalent to what we saw in the Unreal. Other way to do it, we can also can do it with flavor, we can do it with math, okay? We can do a math talk. We can feed the texture here. And we can go and release A and B, because we're not going to use A and B. We're going to use again only R and G. And we're going to multiply, and we multiply it by 0.5. We do here on the off, we channel, okay, that's it. And how we see that we are right or wrong? We just use the difference top. Difference is one pixel minus the other pixel, and we take only the absolute number of it. Is absolute, it's, I'm clear? Yes. Stop me if I'm not clear. So let's see if I did it right.
It'll be the same.
It's the same because it's 0 now. You can see that it's... By the way, here is a catch. When you see black in texture, you need to be careful, maybe it's minus. But, okay, in difference, we don't have minus, it's only plus. That's why it's important also to use the difference talk. Just to remember, just
to make sure.
Just to put it in, because many times it's very confusing. Oh, it's black, why it's black? It's but it's actually a minus.
The map looks simpler than the GLSL.
Yeah, I mean, look, I mean, it's one line. You just delete this line and put this line, so it's very tempting to.
But
if you know GLSL, most of the people who know GLSL use GLSL.
you're probably right.
I'm not like an expert for GLSL, but as time goes, if I can do things with GLSL sometime, the only problem with GLSL is hard to control. It's harder to control. You don't have the visualization, and you need to create
in terms of
again sliders and stuff. So sometimes, yeah, obviously it's more easy
of
to
performance. GLSL is more efficient than the map.
Basically, the math that you see, it's a GLSL operator with some controllers and some more, you know, the developers of derivative doing optimizations, and maybe they take it further with OpenGL commands that are not available with GLSL. But generally speaking, most of the top operators are GLSL underneath. Yeah. So let's delete it. And anyway, it's cool, you know, to show that you're doing something with GLSL. Sometimes you write code because people say, hey, TouchDesigner isn't a programming environment. Hey, look. Okay, let's close it. What is the other one? I don't know. I need to... Compute shader. There is also compute shader in 099, but it's not very interesting for us right now. Okay, so we nicely created something that reminds the scene in Unreal. Let's continue to the next SMB. I will do it quicker because we already know the problems that we need to solve. So first of all, delete the animation, and you see here, it's this container is comprise is made of like 4 elements. That's also not good. We don't want them in containers. We want the 4 elements to be as one surface, and then we will be able to give it a material. Yes, we can also go and divide them, but in this simplicity of this example, I will merge all the surface. You see here, there is a surface. We will merge all of them into one. So I will do it. There are a few ways to do it, but in this case, we will do it very roughly. We're going to extract the SOP information from each container. Wait, oops. Again. We can delete the containers now, and we can merge our subdudes. We can ropa. And we have a one piece. Again, we need to orient it, as you remember. And
scale.
Yeah, you're right. Where we are? Okay, let's scale it. Let's rotate it -90. And we start to remind the same piece that we have. Let's also not forget about the tangents and the create attribute and the normals. In this case, it's pretty normalized nicely, and I mean all the normals are heading nicely. Let's create an out one, like end of chain node. This is just a node. I mean, you also are familiar, yeah, everyone familiar with this. So what we forget anything?
We do the renders outside.
We need not to forget this. 1, 2. To make it available for display on the OpenGL viewer, and the purple to make it available for the renderer to render. And also we need to turn off these viewers. Up and up. So we will have only one node that represents and be able to be displayed in the render and I repeat myself, and the OpenGL viewer. Okay, so we have container, instant container, so let's also cut it out, put the container here, and we're ready to use this base also. Let's give it a material first. You know what, let's start with just place it right in the, but for that we need again, that will help us. Let's make it top viewport, and this is our camera, this is our light, this is our new friend, and let's push it inside the Z. Let's see that I'm not confused here. Yes. You can see here that we are not hitting the if we go into the perspective, we can take it even farther. Yeah, if we go to the front, to the right, sorry, we can even take it farther. Just for OCD of us. And okay, there are a few ways we can instance it, we can do different ways, but I want to change the camera orientation a bit to give it a sense of depth. I want it to be look like that, more or less. Okay. So let's take the camera. Maybe. Just a second. Let's do like that. Out one. Oops. To have maybe better layout of the current one, and this one will be the top viewer. How I make it? I'm not sure. Anyway, we do it that way over there. And we change the camera position. And orientation. Let's make it that way. And let's duplicate the model. I'm not going to do it on the most beautiful, most efficient way. This one, this model, I will create the out SOP. Now we see we have another here. And we can create geometry, and we have another one. And let's copy the translates first. Paste values, and we just need to again go to the top viewport, move it 15, and also another one.
Couldn't you use the same line method you did before?
We could. It's more memory because we are in this case we are only using the same geometry from here, and we instance it. There is a way to instance per point, but in this case we just do another tree just for sake of the. It's called instancing, but this is the most primitive way of instancing. This is a one transform, and we taking the same geometry.
Same source.
Yeah, I'm not sure. You know what? It's not the best. It's not the best example for instance. So don't. It's in this case. It's save this geometry again on the memory, but the same geometry. It's not like we are. It's more efficient. Like it's. How to say it? We are not going to duplicate. Yeah, maybe it's the same. Maybe it will be the same at the end of the day. I'm not sure. We're still computing only one. We're still computing here. We're computing only one time. So if we do here, for example, we do a noise. Okay.
they're both connected.
Yeah, so I don't know why it's not moving, but you see it, both of them are inheriting the same information. But yeah, it's not the best, it's not a good example of instancing. Okay, I can show also an example of instancing if it's.
You actually told me that as long as
the 60 frames.
as long as it's working okay,
Yeah.
don't bother optimizing it as long as.
Yeah, but in this case, I just want to do a tree, but maybe we'll see. Maybe if we have time, I can also do an instancing. It's not taking a long time. It's just do a line, move it to chop, or use a chop and do the same here. You can see here we're going to do another 25. No. And if we look, we have more or less the same, but let's change also the material of this base. And yeah, you know what? Let's do instancing. Instancing. Okay, so for that we can delete all of this. Okay, the problem with instancing that we were not able to interact with it in some cases. That it's not like the actual geometry; it's just replication on the GPU. But let's do it. Let's do it.
You want to replicate the noise as well?
It will replicate the noise, but it will be just the same. So let's make a line just to make it like more clear. Let's take the translates of the line. The line will start basically from 5. And we want 3. Yeah, so we not want the line to start. Sorry, from here. Paste expression, paste values in this case. And we want all the way to this will be this will stay in the same, and here we do a 25, yes, and we want 3. So if we're looking at right now, let's visualize it so we can see that we can see here the line. Okay. And if we want to see also where we display again, and we can see where the points. And now we just take the line. Again, the line is only for visualization. We don't really need the line. But so we're going to take the information of the line of each point and transfer it to chop. Here we have 3 points, and you can see here the difference of the points, like the difference. You can see the values of the points. So all we do, we can also change after that and make some cool stuff. So let's make a null, and let's put it here. With the instancing, we can also not change only location, we can change scale, we can do change other attributes of the geometry. We basically can do a lot of transformation, all the transformations, and okay, we'll see what's the okay. We need now to the transform of the geometry. We need to return to 0. Anyway, that's something else. That's another
reason.
Meetup. We can also talk about just instancing and all the procedures of instancing. There's also lots of information on the way. Matthew Reagan, and there is also in the snippets, help snippets, and many examples. Instancing is one of the most used technique to save to have better performance, to make efficient scene. Okay, so now it's real instancing. Let's delete the line because we don't need the preview of the line. We just need this information. Basically, okay. And for example, we want now to change now the base. Let's just play with it a little bit. Oops, sorry. Let's make noise. And for example, let's move on the Y, okay? And let's make add math. Let's add a noise to we want only a scope of chan 1 and ty. Combine, we want to add, and with removing the chop. By the way, stop me if I'm not clear, like if it's a let's just make it move. So ABS, we can also do it with chop. ABS time dot frame. Okay. And why is not moving?
But you need to connect it to the
Because we are not playing. Okay. Now for some reason it's adding also the why is that? Math should work only on the TY and channel. Okay, so we can also because the Y is 0, so it's not really matter, we can replace it. Replace chop and call it TY. And we just need this number of samples, we just need 3, just here. And we can connect here, connect here. Okay, now it will work. You can see here we reduce the period to really to 10. And roughness. And what else we can add here is the amount of okay. Actually, I would change also the let's change it to 3 and filter. Okay, we have some floating bases here. Okay. It's not the best example, but we will understand where it goes. That's not the that's not the purpose of this example, but yeah, it's nice to see that it's very easy to. Okay. Next, let's control the material. Let's change the material. So we have the base. And let's create a PBR. just drag it here to the material. It's also here on the render. PBR, we don't need a metallic, maybe 0.1, maybe even less. Roughness, we don't need the roughness too much. Ambient occlusion, that's afterwards. That's for now, and we want to bake. Let's bake the, that's another technique, baking the light information. I'm not sure it's the best way to do it. That's really a struggle to do, to have the feeling that Unreal have, because right now you see it's pretty dark and not feeling right. Let's try to render another pass, but in 3D as a cube map. And with this cube map, first of all, I want to change it to, and I want to change the projection. You understand now what I'm trying to do. And from here, I want to do a null. And we're going to close it. I want to do more lights. Okay, let's do another 2 lights. And for that I want to see again the information. I don't need this. I'm going to place lights. So this light is going to be more or less here, and this light is going to be +10. So we have 3 lights, 1, 2, 3. I did it so this won't be black. You see now we have, it's like a 360 camera. Think of it as a 360 camera. And we're going to try to use it as another light. It's like baking in Unreal. Let's go to environment lights. Right now you say there is a loop and there is no map, but let's close it for a second. Let's close this, let's close this, let's move it here, environment map. And now we have a better feeling. Okay, let's look at the difference. Let's see the difference. Let's start to be more close to the Unreal Vision. We don't have the reflections, and we basically from now we can start and place some particles on it and play with it.